Today we'll focus on early phase estimating methods, square foot estimating, historical cost analysis, and when to use uniformat versus master format. These methods are essential in conceptual estimating. Before we start plugging in numbers for square foot estimates, it's essential to understand that there are multiple types of square footage, and each is used for a different purpose in construction and real estate. This slide outlines the key types we'll discuss: gross versus net area rentable versus usable area load factor, using RS means for a base square foot example. If you misunderstand which area you're estimating, your cost could be way off, even millions of dollars off. So let's clarify what these mean and how they apply to real-world estimating. We'll begin with the most fundamental distinction: gross versus net floor area, which leads us to the next slide. When an owner gives you a building program, it often lists how much space they need: classrooms, labs, offices, etc. But this is typically expressed in net floor area, NFA, also known as net square feet, NSF. Net floor area is the space the occupants will actually use: offices, classrooms, labs. Gross floor area, GFA, includes everything inside the exterior walls: corridors, walls, mechanical rooms, stairwells, restrooms, plus the net space. We care about this because construction is priced per GFA, not NSF. You're not just building usable rooms, you're building the entire structure, and your estimate must reflect that. To go from net to gross, we use something called the efficiency ratio, which is efficiency equals net floor area divided by gross floor area. For most schools or office buildings, efficiency is between 70 to 80%. This means if you're told the client needs 50,000 NSF, the actual gross square footage to build might be 62,500 GSF or more. This conversion is critical to get right. Otherwise, you could underprice a project by a substantial margin. Let's go through a simple example that shows how net and gross floor area are connected and why this matters in estimating. Imagine a client says, I need 50,000 net square feet of usable office space. That 50,000 represents net floor area, often abbreviated NSF. This is the space the client actually uses: offices, meeting rooms, workstations, but that's not the full building. We, as estimators, need to price the gross floor area, or GFA, sometimes written as GSF, gross square feet. That includes everything inside the exterior walls, corridors, mechanical rooms, stairwells, restrooms, all of it. To figure out the gross floor area, we use something called the efficiency ratio, which compares how much of the building is actually usable. The formula is efficiency equals net floor area divided by gross floor area. Now, in this example, the efficiency is given as 80% or 0.80. To find gross floor area, we rearrange the formula. Gross floor area equals net floor area divided by efficiency. Now plug in the numbers. Gross floor area equals 50,000 divided by 0.80, which gives us 62,500 gross square feet. So even though the client asked for 50,000 square feet of usable space, we'll be estimating the cost of constructing 62,500 square feet. And that's a big deal. If you had used the net number in your estimate, you'd miss 12,500 square feet of construction. At, say, $500 per square foot, that's over $6 million you forgot to include. That's why we always clarify, is the square footage you're given net or gross? If it's net, you must convert it to gross before estimating. Otherwise, your numbers will be wrong from the start. Next up, we'll look at how this plays out in commercial real estate, where tenants pay rent based on a completely different measure: rentable square feet. Now let's shift gears slightly from gross versus net to rentable versus usable, which is more commonly used in commercial real estate. This is especially important if you're estimating tenant fit-outs, shell and core projects, or mixed-use buildings. Let's define each. Usable square feet, USF, is the actual area the tenant occupies. It's what's inside their suite: offices, open work areas, conference rooms. It excludes any shared space like restrooms, lobbies, or shared hallways. Rentable square feet, RSF, includes everything in USF, plus a pro rata share of the common areas. So a tenant may occupy 10,000 USF, but they're actually paying rent on something like 12,000 RSF because they're also renting their share of the lobby, corridor, and bathrooms. Now, why does this matter for us as estimators? Because tenants pay rent based on RSF. That's the number the landlord cares about. But tenant improvements or build-outs are typically calculated per USF, since construction is confined to the space inside the tenant suite. So if you're working on a Class A office tower and the client says, we're leasing 20,000 square feet, you need to clarify, is that rentable or usable? Because it affects how you price your finishes, furniture, lighting, and mechanical scopes. This distinction also affects programming, stacking plans, and how shared infrastructure is cost allocated. And next, we'll build on this by looking at the load factor, which is the ratio used to convert USF to RSF and vice versa. Let's now talk about load factor, which is another efficiency measure you'll encounter, especially in commercial projects. Where efficiency ratio helps convert net space to gross, the load factor helps convert usable space to rentable space. Here's the basic definition. Load factor equals rentable square feet divided by usable square feet. This ratio tells you how much shared space is being distributed across tenant areas. It's typically greater than 1. Let's walk through a quick example. A tenant's usable square footage, the space inside their suite, is 10,000 square feet. Their share of the building's common spaces, lobbies, corridors, restrooms, adds up to another 1,500 square feet. That makes their rentable square footage 11,500 square feet. Now calculate load factor equals 11,500 divided by 10,000, which gives us 1.15. That means there's a 15% add-on for shared space. Why does this matter? For tenants, a higher load factor means they're paying rent on more space than they're physically using. It's less efficient from their perspective. But for you, as an estimator, the load factor helps in 2 key ways. It allows you to convert between usable space and rentable space, depending on how your project is structured. It helps you determine the total square footage needed for the building when only usable space is provided. For example, if you're told a tenant needs 20,000 square feet of usable area and the load factor is 1.25, you know they'll be renting 20,000 multiplied by 1.25 equals 25,000 rentable square feet. We've now talked about net versus gross, rentable versus usable, and load factor. But you might be asking, when do I actually use each of these in estimating? This slide sums it up. Each square footage metric serves a different purpose, depending on what you're pricing or planning. Let's walk through each one. 1. GSF, gross square feet. Use gross square feet, GSF, for estimating total building construction costs. This includes everything inside the exterior walls, whether it's usable or not. So if you're doing conceptual estimates, structural work, or pricing by system, HVAC, MEP, exterior envelope, always estimate using GSF. 2. NSF or USF, net usable square feet. Use net square feet, NSF, or usable square feet, USF, for programming, interior finishes, and furniture. This is the space the occupants will actually use. So if you're doing flooring takeoffs, casework, painting, or assigning space types in a program, work with NSF. 3. RSF, rentable square feet. Use rentable square feet, RSF, for rent calculations, tenant improvement allowances, and developer pro formas. This number includes a share of the common areas, so it's used in leasing conversations. For example, if a developer is offering $50 per RSF for a TI, tenant improvement allowance, that's not based on just the suite. It includes the load factor. 4. Load factor. Use the load factor when you're sizing a building based on net requirements. Say a program requires 30,000 usable square feet. If the load factor is 1.25, then you multiply 30,000 by 1.25 to get 37,500 rentable square feet, which might influence the total building size or leasing expectations. So as an estimator, your first job is to ask, what kind of square footage am I being given? Then What's the right type to use for this stage or this task? If it's for structure and systems, go with GSF. If it's for fit out finishes, use NSF or USF. If it's a leasing or TI budget, use RSF. And if you're trying to move between usable and rentable, apply the load factor. These distinctions are subtle, but incredibly important to producing accurate and defensible estimates. Let's wrap this up with a clear summary of when and why to use each type of square footage in estimating. Getting this wrong in the real world can result in drastically under or overestimating scope, pricing, and even building size. 1. Gross square feet, GSF. Use gross square feet when estimating anything that touches the full building envelope. That includes structure, HVAC systems, elevators, fire protection, lighting systems, anything that applies across the entire facility, not just inside rooms. This is your go-to for total construction costs. 2. Net or usable square feet, NSF, USF. Use net or usable square feet when you're doing programming, space planning, or interior finishes. 3. Rentable square feet, RSF. Use rentable square feet in commercial leasing, tenant improvement allowances, or developer pro forma estimates. This is the number tied to rent checks. If you're working on an office fit out or pricing tenant improvements based on a $50 per rentable square foot allowance, you're pricing from RSF, even if only a portion is actually buildable space. 4. Load factor. Use the load factor to convert usable area to rentable or gross, especially when a program is in NSF but the building needs to be priced or sized using GSF or RSF. If the program says 40,000 usable square feet and your building has a load factor of 1.25, then you know the total rentable space is 50,000 square feet, and that's what you'll design and price. These terms often get tossed around interchangeably in meetings, but they are not the same, and each has a specific application in estimating. So before you start calculating cost per square foot, stop and ask, what type of square footage am I working with, and is it the right one for the job? Now that we've talked about the different types of area metrics, let's focus on how we adjust costs over time and across different locations. If you're using historical cost data, whether from your own firm, RS means, or a government source, you can't just plug it into today's estimate without adjusting it. Let's break this into 3 key factors you always need to account for. 1. Cost indices, ENR and others. First, cost indices. One of the most common is the ENR Construction Cost Index, also known as ENR CCI, published monthly. It tracks material and labor costs over time. If you're using cost data from 2021 and it's now 2025, the ENR index helps you bring those costs forward based on the national trend. There are also indexes specific to building types, cities, or trades. Always cite your source and year. 2. Escalation, inflation, and location factors. Next, we adjust for escalation, inflation, and location. Escalation refers to expected future cost increases, often applied when pricing a job that will be built in a year or two. Inflation is the general rise in prices across the economy, often reflected in indices like ENR or RS means. Location factors adjust national average costs to reflect regional differences. For example, Boston tends to have a location factor of about 1.14, meaning costs are 14% higher than the national average. If RS means gives a base cost of $450 per square foot, you'd multiply by 1.14 to adjust for Boston, and then by 1.08 if escalation is 8%. That formula would be adjusted cost equals 450 multiplied by 1.14, then multiplied by 1.08, which equals approximately $553.32 per square foot. 3. Adjusting historical costs. Once you apply those adjustments, your historical cost data becomes meaningful in today's context. Whether you're using a school built 5 years ago or RS means 2022 data, your job is to bring that number forward so that your estimate reflects real-time costs in your location, not outdated figures from a different market. Always document your assumptions and cite your sources. This is especially important if you're preparing a conceptual estimate or presenting numbers to a client who may not understand how regional and time-based adjustments work. Let's now talk about how we use actual project data to improve our early estimates. This slide gives you the core principles behind benchmark-based estimating, which is often the first pass we make in pre-construction, before we dive into assemblies or full takeoffs. 1. Actual cost data from past projects. The best source of information for conceptual estimates is your own firm's completed projects. If you've built a school, office, or warehouse in the past, and you've tracked costs well, that data becomes gold. You know the project type, size, delivery method, and final cost, and you can now reuse that information for similar jobs. 2. Use to benchmark similar projects. Benchmarking means comparing your current project to one that's already been built. If you're pricing a new 80,000 square foot school and you've built a 75,000 square foot one recently, you start by asking, how close are the scopes? What systems were used? How much did it cost per square foot? This gives you a ballpark estimate rooted in real outcomes, not just industry averages. 3. Key metrics. Dollars per SF, unit, or seat. Some of the most common benchmarking metrics include cost per square foot, used most in early design, cost per unit, useful for hotels, hospitals, or housing, cost per seat, used for schools, theaters, or transportation. Pick the right metric for your building type. For example, in a school, you may look at cost per square foot and cost per student. In a multifamily project, you might look at cost per unit. 4. Must adjust for year, region, and scope. But remember, you can't copy and paste. You have to adjust historical data to reflect the year, use escalation or inflation indices, the region, use location factors or regional cost databases, the scope, verify if the new project is simpler or more complex. Failing to adjust can lead to bad estimates, even when using accurate data. Historical cost data is not just a reference, it's a starting point for insight. It helps you predict, communicate, and defend your estimate, especially in the early phases when full details aren't yet available. The details are what separate a solid conceptual estimate from a misleading one. 1. Costs change over time and by region. The number one mistake in using historical data is assuming that construction costs stay static. They don't. Labor rates, materials, and subcontractor availability fluctuate by year and by region. A project that cost $400 per square foot 5 years ago in a rural town might cost $600 per square foot today in Boston. You must always adjust for both time and location. 2. Use cost indices to update to current dollars. So how do we make those adjustments? Use cost indices. ENR's Construction Cost Index or Building Cost Index is a great place to start. Other sources include RS means location factors or escalation curves. This helps you bring past numbers up to today's $3. Avoid misleading comparisons to past projects. Be very cautious when comparing your current project to past ones. Ask yourself, are the scopes truly similar? Is the program the same? Were those costs hard costs only, or did they include soft costs? Were there any special conditions like tight sites, poor soils, or accelerated schedules? If you don't ask these questions, your comparisons can mislead both your team and your client. Always include notes or disclaimers when you benchmark. Let's take a closer look at one of the most common tools for adjusting historical construction costs over time, the ENR Cost Index. This slide helps you understand how to use the CCI or BCI depending on the phase of your project and the type of estimate you're preparing. 1. Tracks labor and material cost changes. The ENR Cost Index is published monthly and tracks changes in labor and material costs. It includes 2 key indexes: the Construction Cost Index, CCI, the Building Cost Index, BCI. Both help you update historical unit prices to reflect current market conditions. 2. CCI versus BCI. What's the difference? CCI uses common labor and basic materials like concrete, steel, and lumber. BCI uses skilled labor, including electricians, plumbers, and HVAC technicians, in addition to the same material inputs. So which one do you use? And that depends on the type of estimate you're doing. Use case guidance. Use CCI for broad early estimates based on gross square footage or benchmarking. This is especially useful in conceptual estimating when you're looking at basic structure, envelope, and general building costs. Use BCI if your estimate is focused on systems, like MEP heavy projects, or when you need more detailed trade-specific adjustments. 3. How to adjust. Using ENR index values. Here's the formula. Adjusted cost equals base cost multiplied by target index divided by base index. Let's say the cost you're adjusting was $400 per square foot based on an index of 10/950, and today's index is 13,000. $400 multiplied by 13,000 divided by 10,150, that gives you about $475 per square foot after adjustment. Final reminder, when using ENR indices, always be sure to identify which index you're using, CCI or BCI. Know the original base year for the cost you're adjusting, document your formula, and source in your estimate backup. This way your estimates are transparent, consistent, and defensible. We adjust RS means square foot costs for a specific city and year. RS means starts with a national average, but we have to localize that number to match our project's conditions. The formula is adjusted cost equals national cost times location factor times escalation factor. Let's do an example. Say the national cost is $450 per square foot. The location factor for Boston is 1.14, and the escalation factor to account for price increases next year is 1.08. We multiply. 450 times 1.14 equals $513 per square foot. Then 513 times 1.08 equals $553.32 per square foot. This gives us a better estimate for our local project in today's dollars. Just remember, location factors vary by city. Escalation depends on market trends, and this method works best for conceptual estimating and benchmarking in early design. This slide gives a quick comparison between Uniformat and Master Format, two classification systems we use throughout the design and estimating process. Uniformat organizes costs and scope based on building systems like substructure, shell, interiors, and services. Master Format organizes information by trades or materials, things like concrete, masonry, mechanical, or electrical. Each has its place. The key is knowing when to use which one, depending on the level of design detail and the type of communication you're having, whether it's internal to the estimating team or external with the owner or architect. Uniformat is structured around building systems, and it's incredibly helpful when your design is still in its early stages or when you're talking with non-technical stakeholders. The major categories are A, substructure, B, shell, C, interiors, D, services, E, equipment and furnishings, F, special construction. This format is best for conceptual estimating owner-facing communication because it's organized in a way most clients understand system-level cost comparisons. So you can evaluate major decisions like precast versus steel frame and for aligning with early schematic design documents. Master Format is the industry standard when it comes to organizing construction documents, specs, and trade packages. It's organized by trades and materials using 50 divisions, although we commonly use divisions 00 through 33 for most building projects. Examples include Division 03 for concrete, Division 26 for electrical. Master Format is best used when you're developing CD phase or bid level estimates, you're managing subcontractor buyout and procurement, or writing specs and aligning scopes to detailed drawings. This is the format you'll use when you get into trade level detail or start issuing bid packages. So let's summarize. When should you use Uniformat and when should you use Master Format? Use Uniformat when you're in the early phases of design or estimation. It helps with conceptual design, estimates, high-level scope breakdowns, communicating with owners, performing value engineering at the system level, like swapping out HVAC strategies or shell systems. On the other hand, use Master Format when you're preparing detailed CD or bid phase estimates, organizing subcontractor bid scopes, writing specifications, or doing detailed material takeoffs. Think of it like this. Uniformat equals big picture systems. Master Format equals material specific detail. You'll often use both on the same project, just at different stages and for different audiences.